Hello, class. All right, so we're going to revisit an example here. This example is an example we just did on a previous page, but we did it with just mathematics. And now we are going to use essentially this GeoGebra calculator, our probability calculator, and determine how to use it to build this confidence interval. So let's read over the problem and make sure we understand what we're doing. So here we have college students and marijuana legalization. National surveys show that about 43% of American adults support legalization of marijuana. What proportion of students at Capital Community College support the legalization of marijuana? Suppose students conduct a survey. They randomly select a sample of 400 students, and in the sample proportion in favor of legalization is 55%. There's our P, right? Here's our N. Calculate the 95% confidence interval. So we want 95% between these two numbers. We are not going to use this probability model. We are going to use instead in GeoGebra. So when you click on this link that I provide you, you are going to use GeoGebra, and you're going to have to come over to this tab, this separate tab that's called Statistics. So once you get into this tab, then you have a pull down menu of all the different tests and all the different estimates we're going to do. Right now we are estimating. We are using a confidence interval to help us estimate the true population proportion, though we are not sure if we really know it or not. So, all right, so we're going to do a test on estimate of proportion. All we have really is just a singular proportion, right? The other option down here is our difference of proportions. We're going to get to that later, but right now we're just doing an estimate of a proportion. So we are doing a confidence interval of proportion, and when we do confidence, we are estimating that actual population proportion, or trying to, I should say. So I'm going to use this test, this estimate of a proportion, I should call it. So when I come into here now, I have to enter the confidence level. Yes, it's already entered there for me, but I just want to show you that you can enter the percentage of the confidence interval, confidence level, confidence interval, same thing, same phrase. So down here now, I got N and I got sample of successes, and it took me a little while to figure out what sample of successes meant, but N is your number of students. I have 400 students. The sample of successes is how many students out of this 400 you would get saying, yes, I want to legalize marijuana now. So how do we find that when we are not given that information? Well, we use the sample proportion, the p hat. In other words, the p with a little symbol over it, right? Just like a little arrow pointing up. It's called that is this symbol. Let me just show you. It's on our thing. So P hat is what I'm talking about. So there's the symbol with the hat. So, all right. So if I wanted to do this, if I wanted to figure out P hat, really, well, this is P hat. If I wanted to figure out how many students actually said yes, well, I could use 455%. We literally just multiply them together. So 55%. And then I would use a little asterisk symbol on my keyboard to help me multiply by the sample size, which is 400. Now, if I hit enter while I'm still in there, I haven't touched anything else, it'll calculate it for me. 220 students said yes to this idea, so of legalizing marijuana. So, all right. So this is all the information I need to put in. These three things is all I need to put in, and it spits out everything I need down below. So here is our confidence interval. So let me come over here. Confidence interval is, right, we can say, we can use this notation of what's called set notation. We can say, okay, well, our confidence interval, we have a lower limit of basically 50%. So point 0.5012, all the way to, it could include, it doesn't need to include that, but it could include it, and all the way to 59.88%. So I'm saying the percent, but this is the decimal there. So that's one way to write it. Then another way to write it is with inequality notation. So another way to write it is like this. So with our P, we are estimating our P, our population proportion. So I'm going to put a P right there. So I know P is between 0.5012 or 0.5988. So somewhere between 50% to 60% really. Is where our P, our population proportion, is somewhere between there. And we are how confident? We are 95% confident that is in between there. So these are our confidence intervals. Just to say it, another way to write it is that last little bit. You take the P hat and you add and subtract. I got to insert something here for add and subtract. 10 years later. My computer's acting really slow right now. Okay. There we go. Did it work? There we go. So plus or minus. Sorry, that I don't know why my computer's acting so slow. So we could do our P hat plus or minus the margin of error. The margin of error, which is 0.0488. I got that from down here, right? So it's another way to write the confidence interval, right? Here's the confidence interval, the lower bound, the upper bound, and here is the interval. Notice also this gives us the standard error as well, which we can possibly use to our benefit if we need it. So these are three different ways to write the same thing, and GeoGebra gives it all to us. So the last little bit I wanted to say is a lot of times we do talk about the margin of error, and I just want to point it out to you to make sure that we understand where it is. So the margin of error, sometimes we just call it ME, is equal to 0.0488. So that is the margin of error. All right, just to show you, we got the same thing. I have down below the information we had from our previous work there. There it is, and it is the same. It's just rounded a little different. So yeah, it is rounded to this third decimal, so properly. So there we go. We have the same thing. All right, so that's that. I did want to show you one more thing just to kind of bring it into big picture kind of thing. But if you are done with listening to me, go ahead and end this. Bye-bye. So, all right, let me just show you one more thing here just to make sure we understand what we are literally talking about here. So we did have the standard error listed over back on the statistics back here. So what was the standard error? There it is, 0.0249. So let me come over back to the distribution. 0.0249 was it. I'm bad at memorizing this stuff. 0.0249. The mean, which was what we consider to be essentially P hat. So P hat is the mean. So we got point 55 was the actual P hat. So, and then if I pull this out, I'm just going to actually enter our confidence interval in there. So 0.05.50. I can't say numbers today apparently. And then the last one is we're going in between 0.05988. Just big picture here. Enter. Look at that percentage. That is our confidence interval right there. This is showing our confidence interval of what we have. We are 95% confident because all of our all our possible samples of this size are contained in between these two. That we are 95% confident that the true population proportion of people of Capital Community College students who support the legalization of marijuana is contained within these two numbers from 50% to 60%. All right, so I'm just trying to bring up big picture ideas. So I hope that helps. Good luck, everybody. Bye.